Before we start implementing our moving average filter, let's group common terms in our expressions to simplify the code we will write. We can start by writing delta x bar as the current average minus the previous average. We can see that this term appears only twice, here and here. Next, notice that the difference between the current measurement and the current average times the difference between the current measurement and the previous average occurs 4 times. Here, 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 and here. Let's call the term delta S1. Also, the negative difference between the oldest measurement and the current average times the difference between the oldest measurement and the previous average appears twice, here and here. Let's call the term delta S2. Moving on, the term x bar sub k minus 2 times the previous average appears 3 times, here, here, and here. Let's call the term t. T can be reformulated as the current average minus the previous average minus the previous average, which is equal to delta x bar minus the previous average. Now let's define a quantity little n as the minimum between k and big N. Also, let's define a quantity f, which is equal to 0 if k is less than or equal to n, and it is equal to 1 if k is greater than n. These two quantities will help us simplify our moving average filter formulas, as we will see on the next slide. Alright, our average value calculation can stay the same. However, delta x bar can now be calculated as the current measurement minus the previous average divided by little n when k is less than or equal to n, and it can also be calculated as the current measurement minus the oldest measurement divided by little n when k is greater than n. Next, the standard deviation can now be calculated as 0 when little n is equal to 1, and it can also be calculated as the square root of the sum of squares divided by little n minus 1 when little n is greater than 1. Moving on, the current sum of squares calculation stays the same. However, delta s can now be calculated as delta s1 plus f times delta s2. Next, the skewness coefficient can now be calculated as 0 when little n is less than 3 or when the standard deviation is 0. And it can also be calculated as little n divided by little n minus 2 times the sum of squares times the standard deviation, all that times the sum of cubes when little n is greater than or equal to 3 and the standard deviation is greater than 0. Now, the way we calculate the current sum of cubes stays the same, but delta c can now be calculated as delta s1 times the current measurement plus t plus f times delta s2 times the oldest measurement plus t minus 3 times the current sum of squares times delta x bar. And that's it. Everything we need to implement our moving average filter is on this slide, and that's exactly what we are going to do in the next video. Thanks for watching, and see you then.